Very much for introducing me. So I'm working for a wind turbine operator in a project, and my work is mostly dedicated to what is happening on the Synedge device. So in the next few slides, I will introduce you to two use cases, and will demonstrate or give you an overview how Synedge is used in these use cases. So the first one is a more general use case that is going on for 4 or 5 years. So we have to to enable a wind turbine management remotely. So the industry, as many industries, have a specific challenge, and for wind energy operators, it's about the technical complexity. There's an additional complexity that the geographical areas where these wind turbines are situated might be quite remote, and this plays a vast role in how to organize your physical access to the wind turbine. So imagine if you are operating wind turbines in the south of America, in Chile or somewhere else, in remote places, it takes several days to get a service technician to this wind turbine to do any maintenance. So in every information or every step that can be done previously or remotely plays an important role to operate these turbines efficiently. So these, and in addition, this operator through merger acquired another generation or other generations of turbine, which adds to the hardware complexity. So you have different generations of modern turbines that are equipped with different controllers, different IT equipment that requires handling of operations differently. So we have different architectures, mixed architectures. Some are x86 based or AMD based platform, different OS distribution that have to be taken into account when rolling out your business logic. So the overarching goal is to reduce the complexity so that you can manage turbines remote, unified, and it doesn't make a large difference if you are managing a turbine of this generation or this generation when you install a new update, or if you run some maintenance operations. Then security plays an important role. So this is important to integrate the onboarding of devices, as we have seen with the certificate authority from Cumulosity. We are using in this project, we are using a different one because the PKI the life cycle of the device should be managed from the beginning of the production at the factory where the controller is produced, and so it should be shown that this device was handed over from the manufacturer to the wind turbine operator, like and this has to be managed in a kind of ledger where you can follow up when this device was taken over, and it has to be managed from the cloud, because you want to manage hundreds of thousands of units and roll out software updates, configurations, or other operations simultaneously in a controlled manner. How this is achieved, we can take a look at a high-level architecture diagram. So I would like to lead you through this diagram from the very bottom. So at the very bottom, you see two different types of controller which are connected to the internet over LTE or other mobile networks. So on the left side, we have the Phoenix BPCs. This is a Yocto-based Yocto-based system, and this has there's a small error. So it uses TPM a TPM2 module, which is the one on in the green box on the bottom. So and underneath we have the controller, which is an ARM-based system. So this shows that we have a high variety of different hardware and OS systems, which require different solutions how you deploy your agent. In this case, it's SynEdge. For the Phoenix device, it's deployed as a container-based solution, and on the right side you see different business containers, and these business containers, they are used to do specific business operations. For example, the device manager, when the device is first time registered. So the PKI provider, which has issued a new device certificate. This device certificate is trusted in Cumulocity. Then the device manager takes over and sends some information to the Cumulocity cloud, which you see here on this side. And here, the SynEdge provider knows, okay, I have now a technical device which needs to be assigned and to the right hierarchy, and we want to assign a specific turbine, because the turbine and the physical controller are managed independently. But now the SynEdge provider, the business logic is that it knows, okay, I have to take over a wind turbine that was sent by the asset management to my to Cumulocity. So that is a kind of business logic that is carried out, that is performed during the bootstrapping. Once all of this is done, the solution can operate. So from a subcontroller, it can send some from which is handled as a child device using SynEdge and the MQTT broker and the bridge, which we have seen before, to the cloud, Cumulocity cloud, which runs a remote control center. Then you see, for example, that the temperature in this location for this wind turbine is such and such degree, or you could see the information on some configuration information. So what software version is currently run on the controller application for this. Okay, now we want to see if we have to change, for example, parameters. So these parameters, they play a very complex or a very important role in operating a turbine. You can imagine a turbine, it's like a small factory, so it has thousands of parameters that need to be configured. And these parameters, they are managed by the parameter management, and how they should behave is defined here in the configuration management. And the configuration management sends over then its definition to Cumulocity, and the parameter management manager then sends the as-is information and a parameter service then finds out if some information needs to be taken, for example, because the the wind direction and the set wind direction and the actual wind direction are too far off. So we need to go to the remote control center and send an information to the turbine to adjust its nacelle to increase efficiency in this case. So it is important to understand. So here on the right side, we have a different different type of controller. So that is the legacy fleet, and so we have to manage to be able to run the same business logic as on the other generation on this one as well. And this is a nice way to abstract the technical differences so that you can run the same business operation on your new generation as well as on your legacy generation. And another important aspect here is to see that all of this complete solution, it is part of different business processes. For example, if a new wind turbine is registered, it is automatically registered here in the asset provider. It's powered on, then the device manager takes over and registers or assigns the new provider, new turbine. Or for example, access management. So all of these information is configured separately in so in external applications, but at the same time, it's important to consolidate this information to the cloud and in the end use it here in the SynEdge device to operate the wind turbines through these controller applications. So that sums up the first use case that I wanted to show to you. The second one is a more specific one. So this is about managing licenses remotely. So what we will see in the next two slides is the as-is situation. So you will see how currently it requires to access the controller to roll out a new license or to revoke a license. That is quite cumbersome because it requires physical access to the turbine, which might be time consuming and requires additional costs to travel to this turbine or whatever. So this is very rigid, and it is not open to new ways of managing your license. So for example, if a wind turbine needs an additional component for de-icing the rotor plates, this might only be needed for a certain period of the year. So so the operator can shift a license from a location where it is needed at the moment, and in 3 months it's not needed, to a location where it's needed then after these 3 months. So it's a concept of revoking or borrowing licenses, which requires a more flexible solution in this case. So the first part will be, we take a short look at how it is operated today using a local PC that runs as a proxy to manage licenses, and then we transform this solution to a centrally managed solution from the cloud, and SynEdge plays an important role in this. So the first slide shows here on the right side, we don't need to go into all the details, but here I want to that you pay some attention here to the middle. So this is this activation wizard, which mediates to the license service which runs in the cloud and the physical device that needs to issue a new license. So, for example, I want to issue a new license to this controlling unit that is responsible for de-icing the rotor plates. So someone needs to travel to this this turbine, set up this PC, activate the license, and all of this goes back and forth. So so that is how it currently works. Another shortcoming is if, for example, this device breaks, the device is locked and cannot be used any longer. So in the next step, in the 2B architecture, we transformed this, and so you can see the same players as we have seen before. So you can see here the Phoenix BPC, and as well some the license service, which was shown in the previous slide as well, and Cumulocity Cloud. So there will be an additional business logic in Cumulocity Cloud to take over the role of the activation wizard. So the activation wizard can either be run for a single turbine, or it can be done in a bulk operation. So, for example, if you want to roll out new licenses to a complete park or to a region, so that would be done then as a bulk operation. And the sequence diagram, or the license, the BPCs that we have seen in the sequence diagram in the middle, the business logic, this business logic is mainly part here of this microservice. And now we turn our attention here to the important part here, is the thin edge. So thin edge is running on this Phoenix BPC, and to add this business capability of handling license or issuing licenses and carrying out the specific steps. So we will implement a license manager as a workflow. So Ruben mentioned this concept before. So that is part of this solution. And what will happen? So in the sequence diagram that we have seen before, we have seen that there is a sequence or a change of invocations from the license service as well down to the Phoenix BPC, and this will be proxied here through this microservice running from REST and sending it down as MQTT or as operations, and the workflow then will propagate this to a gRPC layer that is then understood by a Phoenix component, which is called the remote service call. So that shows how easy and flexible it is to extend and adapt thin edge to this license solution. And that's something that we look into. So that will be standardized not only for this wind turbine operator, but it will be standardized to be used by other Phoenix customers as well. So that was basically what I wanted to show to you. If you have any questions, please feel free to ask them now.
Are there any questions for Christof? If not, then maybe just sink in.
Maybe a question for me.
Go for it.
So regarding kind of the deployment of thin edge, was it explored? So it's always a question, how do I deploy it? Some people want to use containers. Some people want to, run on bare metal on the Linux operating system. What was the reasons in this project not to use the bare bones like natively on the Linux and use containers?
Okay, in this context, so basically it was the flexibility and the release cycle. So for Phoenix BPC, they roll out a new base image, the PLC Next operating system, half year or quarterly. So, and this turned out to be not as flexible as it was required in our case, and we wanted to split this responsibility to give the operator or the customer a better flexibility to include the most recent thin edge release and with the most recent features. So in order to, so this should be TPM2. So so in this context, we had recent development, so that required rolling out and testing new versions more flexibly.
Okay, so a more bundling kind of topic to saying, this is my solution. Everything is in a combination of containers. That is kind of like my IoT solution. That's a little bit easier to test.
Yeah.
Okay. But it's good that it's flexible too. Sometimes that makes sense, sometimes it doesn't. It really depends on the case.
And I think another important aspect was it was easier than to isolate from the hardware specific requirements from this from the two different generations in this case.
Yeah. Okay. Cool. Thanks.